All right, well, I'll get it kicked off. Thanks everybody for joining in to our monthly webinar. My name is Alex Zamzes. I'm applications engineer here at Belzona Houston. And today we're going to have a fun one. We're going to do our Believe It or Not, and we're going to go through some of the unique acid rehabs that we've done, like this pump right here. We've done a lot of equipment where it might seem like something that you want to replace right away, but it could turn into a valuable asset, whether it be a spare pump, like what we're looking at here, or repairing something and keeping it in service to extend the life of an asset. So let's kick it off. The first thing we're going to talk about, and it'll be meshed in there throughout the presentation, is I'm going to go over our Belzona products, just give a brief overview, especially if it's good if you're not too familiar with our products, but just show you what their capabilities are, what kind of characteristics they have, and what makes it possible to do some of these applications. So we do have data to back up how we make these repairs reliable. We definitely, some of these you might ask, like, how are you sure that's going to work? Well, we use our data, we use our case histories, and we put together procedures and applications that we know are going to work well. So let's jump right into it. So first off, I'd say what we're famous for is our rebuilding products. What you're looking on the right there, that's our classic Belzona 1000 series paste grade material. I'm sure you guys are familiar. It's like a gray product, kind of like a peanut butter consistency, and it's used to do those miracle jobs where you have really deep pitting or a hole in a pipe or a flange face that's totally eaten up. And then all of a sudden you can use these products to rebuild those surfaces and create totally new surfaces. And once they cure, they're hard. I mean, they're almost like steel at that point, very abrasion resistant, corrosion resistant, and really high adhesion. So you're talking 3,000 to 5,000 PSI. So these are built to not come off, built to withstand, extreme conditions, extreme chemicals, pressures, and temperatures. And besides our epoxy putties and rebuild materials for steel, we do also have materials that can repair concrete, like you're seeing in this upper picture, and rebuilding materials for rubber as well. So the good thing with these products is they can be applied thick. They can rebuild, as you see here. This is a vertical overhead where the rebar is exposed and the concrete's totally eaten up. We can rebuild that. We can do deep pours with our concrete. We have polyurethanes that can be applied, 1 to 2 inches thick to repair thick rubber systems like this floating hose. So beyond the steel, which is what we're famous for, there are other substrates we can repair, whether it be concrete, rubber, fiberglass, HDPE. So we've done several different types of substrates as well. Now, these same materials can be used in what we call plate bonding, which is, when people see this and they're not familiar with Belzona, it's really a unique and believe it or not type of application. But, instead of welding, doing like a lap weld patch, or even welding in new equipment like this hatch to this on this flange hatch on a ship here, we can bond them in with those same rebuilding materials, and they are going to be adhered solidly to the substrate. So like I said before, 3,000, 5,000 PSI adhesion, these plates are not coming off. So when done correctly, this full flange is bonded down, so the full adhesion is going to give you that same strength as a weld around the edge. And you can do it in scenarios where you might not be able to do hot work. So definitely versatile, and that's what allows us to do these applications that can sometimes wow people. So going into one, this is a exhaust pipe that was handling, 400-degree flue gas coming through. And you can see this is one where you might think, man, we're going to have to shut down, unbolt this flange, total replacement, or cut it out, weld it. But we were able to come in and do a bonding of a plate. So we used our rebuild material. That's a high temperature paste grade material. And we bonded a plate over the hole after we've done some surface prep and cleaned up the metal. Bonded this plate. You have that 5,000 PSI adhesion that's going to hold it down. On top of that, we used our material to wrap around and really create a cast. And that holds all the pressure in there, rebuilds that huge hole that you see there, and makes it stronger than it was before, corrosion resistant at the same time. So this might be a unique application that some people might have not even considered repairing. So how do we do these applications, when it comes to cold bonding? This on the right here is an application where instead of welding on brackets onto this tank, which was in service, they bonded it with our materials, and we calculated how much load it could handle. So when we do these bonded repairs, we're able to calculate what kind of loads they can handle. We look into the failure modes, mechanisms, what's going to attack the plate, what's going to cause any debonding or cracking, and we really analyze the repair before we get in there and repair it. And we also look into application. What kind of surface prep can we do? What kind of access do we have? What's going to be there during the application? Are there going to be chemicals spilling on it? Is it going to be inside of the tank? So we really, to get these applications done, like the one you've seen before, it's not just go and slap it on. You have to look at what can happen during the application, design the proper size plate, get the correct surface prep done, and make a detailed work procedure and QA/QC throughout the application. Now this is another one, just showing you what kind of strength we can have with our bonding. This was an application where they had to move some tanks, 22-ton riveted storage tanks that were at the end of their life. So they were just trying to get them out to bring in a new tank, and they didn't have time they could not do any welding and cut it and remove it. So they just wanted to get it out of their way for a turnaround. So we did calculations and found out how many plates we'd have to install to be able to, use that to lift these tanks up. So we did a calculation for a 420-ton lift to have some safety factor, which was still cost effective at this point, more cost effective than what they had to do before. And we were able to safely lift these tanks up and move them to where they had to go. So that just shows you what kind of bond strength you have. And the way we calculate this is we see these plates are going to be under a shear load. So we use our shear adhesion values, calculate the dimensions of the plate multiplied by the adhesion. That's how much weight they can hold, send the data over, make sure there's safety factor, make sure there's QA/QC throughout the process, and get the job done correctly. So these can also be used for leak sealing. So you might look at this leak here and say, that's not a leak that can be sealed live. However, when you have the right procedure and the right products, this is something that actually can be sealed live. I mean, this is not an easy repair, but it can be done. As you can see here, we bonded a plate, but we also fabricated a plate that had an orifice valve running through it. That way that the leak could vent out of this hose while they bonded down the plate. Now, what do you need to get this done? You need products that can stick to a wet surface, because even though we have this venting plate here, there's still, water is going to splash around the surface. So we do have rebuilding materials that can be applied underwater. They have hydrophobic properties that repel water. So you need those. You definitely need quick curing products, because if your product doesn't cure quick enough, even with the venting device, it's going to find its way through the plate. So you have to have surface tolerant, quick cure, rebuilding products, because you definitely want something thick so you're not having to have a perfectly made plate. So our rebuild materials can be applied at certain thicknesses that give you some give and allow you to bond that plate down in the field where things can be difficult, and they cure fast. So you need all those to make this, and then of course you need the ideas and the procedures and the technical guidance along the way. So this is something that was planned out quickly, because when leaks happen, you don't have much time, but we have the resources, we have these types of procedures in place, and we just have to modify them per the job. So once the plate was bonded down, ratchet strapped here, once it cured, you can remove that, and typically we wrap it, which I'll get into in the next slide. We use a composite wrap to really cast it in place, and then once everything's cured, you can close your valve and your leak is stopped, and that's what you see. So pretty crazy application. That's definitely probably the biggest leak we've tackled, but we've done a similar type repair on smaller leaks, and with a lot of success. So going into wraps, composites, they can be applied in a wrap form or a patch form. As you can see here on the right, this is actually a column that was fully circumferentially wrapped. So we do have our ASME engineered composites, and that might be a believe it or not to some people too. There are the ASME engineered composites where you can actually calculate pressure ratings for composites and repair piping in situ with an ASME stamp and PE stamp behind it. You know, we have our rapid cure composites, which we talked about, our rapid cure products and our surface tolerant products. We can use those in a wrap form and do sweating pipes and leaking pipes and other things. And of course, as you can see, we've done leak repair as well. So going in, I mean, this is something, you know, when I show it to people, I feel like they're pretty astonished. So, I mean, this is a tank that most people might have just put in out of service, you know, just, you know, kill it, take everything out and throw it away. We found a cost-effective way to wrap this and create a tank around this tank with our composite material. So this is a carbon fiber fiberglass mesh mixed with a corrosion-resistant epoxy. Once they're mixed together, this forms a hard composite, and they were able to reinforce this tank shell, make it corrosion resistant from the outside so it has no longer CUI issues, and also provided strength and pressure retention so that it seals everything and is a, you know, works as a good tank. And believe it or not, it is a approved repair as per API 653. So if it's designed with the standard, which we have our composite material that's compliant to ASME Article 401, if it's designed using this standard on a tank, it can be an approved API 653 repair. So this right here, what you're looking at, is a way to efficiently repair your tank in an API code. You can do this in situ, would not have to drain your tank and clean it. You can do, you know, different repairs without having to do any welding, lap welded patches. So this could really get you to your next turnaround, or it can be your repairs during your turnaround. So it can be done both ways. And then this is a steam leak here coming out of a stripper. So they had, you know, stainless steel, and they had some chloride stress cracking at the welds. So we were able to come in here and actually, you know, stop this leak in service and come in and wrap it. And then, you know, we did about half of circumferential wrap. And then during a turnaround where they had a little shutdown, we were able to come in and wrap the whole circumference to do a full wrap with our ASME engineered system. So it might not be an application that you've thought about before, but it is capable of holding, you know, heavy, high pressure scenarios, you know, in the thousands PSI, and is applicable to pressure vessels, tanks, pipes. I mean, we've used it on pumps and heat exchangers as well. And then this is a flare. You know, this is a nozzle that was taken out actually during the freeze. They had to shut down, and they did some repair work, and they removed the nozzle. And one of our applications, so this is combining two things that we've talked about: plate bond over the hole and composite ratch over the plate bond for extra pressure retention. So this is a lot of pressure retention. I mean, we've done testing with this system, and it's hard to make it fail. So it has a lot of adhesion. That's what keeps it there, and that's what allows it to resist the pressure coming out of that hole. And the composite wrap is engineered to give it more strength to that section as well. And finally, going into our coatings, which is, you know, besides the rebuild and the, you know, the Belzona 1111, the famous putties, I'd say our coatings are well known across the industry as really those coatings where you open up a pump or open up a heat exchanger 10 years later and it works. And I mean, you know, we do have a good reputation for coatings that last, and I think that's a believe it or not right there. But we do have some applications where, you know, people might, you know, really say like, oh, I've never even thought about doing that, or I would never have thought to do that. So this was a tube sheet, not too big, just a little tube sheet, but it was leaking at the interface of the tubes in the tube sheet. Stainless steel, critical equipment, expensive. You know, even though it's small, it's a stainless steel tube bundle. Takes time to make them, to get a new one fabricated, and they really needed this one quick. So we came up with a plan to use our fluid grade material. We have a lot of fluid grade materials that can be applied thick, so they have no thickness limit. They're very cohesively strong. So we created a former around this tube sheet and poured it in about an 1/8 inch thick to really cover that interface, and it worked great. It was a quick application, did it in one day, and saved them a whole lot of time and panic to try to get a new bundle or anything made like that. So it was a quick turnaround, helped them a lot. Not your typical application. We do a lot of tube sheets, but not in this way. So believe it or not, you can have a pump with a cutwater that's totally chipped off, and we can make it look brand new. We do this quite a bit. I think, I was trying to look for some other pictures, but this is probably one of the better pumps that we get in. We get some pumps that are totally destroyed, and we bring them back to make them look like the pump on the right. But this is pretty typical for us. Again, those rebuild materials, they can be used to reform, vane edges, cutwater edges, obviously fill in all that pitting that you see on the casing. And then we can use our coatings to protect all that rebuild, protect all the substrate, and make it a brand new pump at that point. So we can take a lot of times people will get a new pump, we'll coat it with our coating, and then they'll give us the spare pump, and we'll use our rebuild and our coating so they have a good spare pump to go with that pump as well. So our coatings can really reform an asset just like what we're seeing here. Well, this is one you see channel head with a divider plate, if you want to call that a divider plate, but I would say your fluid flow would be mixing here a little bit more than what you want. So this was during a turnaround. They were not expecting this. The corrosion was probably plugging these holes here more than they realized. But once it was blasted, the metal loss was really exposed, and you can see that divider plate is no longer dividing much. So we were actually able, over the weekend, without any welding or anything like that, able to recreate a divider plate using our rebuild material. And then with our coatings, we're able to coat everything and just make it a whole new channel head. So this is now corrosion resistant. You can see we even rebuilt the divider plate here so that it fits properly in the gasket. And we're going to make this heat exchanger more efficient. They didn't have to buy a new one, order a new one, wait for a new one, and we made it corrosion resistant all at the same time. So it's not going to have this same issue as it did before. So this is something that you might see and think, that's no way we can fix that, but there is always a way when you have the right materials and the right application technique. And then finally, one thing that, definitely when I was first coming to this industry, someone told me you can paint stuff underwater, and I didn't really, I'm like, wouldn't it just all go away? And actually we do have some coatings that can be applied underwater. So you can see here, especially offshore around the splash zone, you have a lot of corrosion at the legs and other areas that are immersed sometime and sometime not immersed. So this coating has hydrophobic properties where you can mix it, go underwater, and I've seen it on the paintbrush and it just does not come off. So it does not mix with water. Put it right on the substrate and it will wet out the substrate and stay on the substrate. And even with waves and stuff, it does not get splashed away. So believe it or not, we can coat things underwater. And where does this have application? You might say, well, nothing at my plant is underwater. Well, some of the applications could be leaks, could be sweating pipes, could be we need a coating today and it's going to be 100% humidity for the next 2 days.